Welcome to qnawire.
In this problem, we need to solve for letter A, the angular velocity of the rod after the impact, and letter B, the velocity of the sphere after the impact. So I have here a sketch of the problem. So you can also see here the dimensions, the velocities, the given masses, etc. So a sphere with mass md strikes one end of rod AC, which is actually point A, with a velocity v1. The rod has length L and mass center G. This produces an impulse at point B and causes the rod to rotate with angular velocity omega 2. Its center of mass to move at a velocity vg, and point A to move with a velocity VA. Also, after the impact, the sphere now moves with a velocity V2. So, before we start, let's first convert some of the given values so that our units would be consistent. So, the length is 750 millimeters. So, multiply this by the conversion factor. So, 1 millimeter is equal to 10 raised to negative 3 meter. So, this would give us 0.70 meter. And then, the mass of the sphere, MD, is in grams. So, 800 grams times the conversion factor, 1 kilogram equals 10 raised to 3 grams. So, this would be equal to 0.800 kilogram. And then we can also calculate already for the moment of inertia. So, given its shape, the moment of inertia of AC, or rod AC, is equal to, so 1 over 12 m AC, mass of the rod, times the length L. So, this would be equal to 1 over 12 times 2.4 kilograms times 0.750 meters squared. Sorry, this is squared. So, we'll have, so I equals 0.1125 kg meters squared. There, so these are our given values. So, after the impact, so we have the linear velocities after the impact can be expressed in terms of R and omega. So Vg would be equal to L over 4 omega 2, because as you can see in the sketch, point B is the point of rotation and G is at a distance of L over 4 away from point B. Because A to G is L over 2, so B to G is L over 4. So the same thing with VA. So VA is also equal to L over 4 omega 2. Now, so applying the principle of impulse and momentum and taking the moments about point B with a counterclockwise direction taken as positive, we'll have the equation md v1 times L over 4 equals, so md v2 times again L over 4 plus, so I omega 2 plus MAC times VG times L over 4. So, we can substitute the equation for VG here and for VG. So, this will become, so MD V1 L over 4 equals MD V2 times L over 4 plus, so since both terms will now have omega 2, so we can factor out omega 2, so it will be I plus, so MAC, so L over 4 squared times omega 2. So substituting the given values, this becomes, so I'm going to omit the units for simplicity. So this will be 0.800 times 3 times 0.750 over 4 equals, so 0.800 times 0.750 over 4 times V2 plus, so the value of I 0.1125 plus 2.4 times 0.750 over 4 squared, then times omega 2. So simplifying the equation, so this will become, so 0.45 equals, so 0.15 times V2 plus 0.196875 omega 2. So this is now our equation 1. Now, so using the equation for the coefficient of restitution, so we'll have, so E equals, so negative V2 minus VA over, so V1 minus VO. So this will be, so negative E, V sub 1 minus O equals V2 minus VA. So substituting the values, so this will be, so negative 0.5, so because it's given in the problem that E is 0.5, and then 3 meters per second, then minus 0, so that would be 0, and then equals, so V2 minus, so 0.750 over 4 times omega 2. So simplifying that, we'll get, this will be, so negative 1.5 equals V sub 2 minus 0.1875 omega 2. And then finally, so V2 is equal to 0.1875 omega 2 minus 1.5. So this is our equation 2. Now, to solve for omega 2, so we can substitute equation 2 to equation 1. So we'll have, so 0.45 equals to 0.15 times 0.1875 omega 2 minus 1.5 plus, so 0.196875 omega 2. So this will be 0.45 equals, so 0.028125 omega 2 minus 0.225 plus, so 0.196875 omega 2. So combining the terms with omega 2 and then transposing negative 0.225 to the other side, so we'll have 0.225 omega 2 equals 0.675. So therefore, this will give us omega 2 is equal to 0.675 divided by 0.225. So that would be, so omega 2 equals, so 3 radians per second. Then as for the direction, it's clockwise. So this is our answer for letter A. So for letter B, we need to solve for V2. So we'll use equation 2 for this. So V2 is equal to 0.1875 times the value of omega 2 minus 1.5. So this is equal to negative 0.938 meter per second. So the negative sign here indicates that the direction that we assumed is opposite of the actual direction. So hence, V2 is equal to 0.938 meter per second up.